All right, so today we're going to look at data analysis. All right, so besides the raw data, how else are you going to look at your data? Okay, so here's the raw data right here. All right, but how are you going to look at this data? All right, now you guys can calculate the average, right, and that can tell you whether the averages are different or the same. Okay, but what that does not tell you is how much of a difference do you need for you to accept the alternate hypothesis. All right, so there are actually two statistical analysis tools that tells you how much is enough. All right, or how much of a difference there is, or how significant that difference is. All right, so one is the ANOVA, the analysis of variance, and the other is the t-test, comparison between two means. All right, now do understand that if you choose to use one of these tools, analysis tools, you have to make sure your hypothesis matches what the tool does. All right, so for example, the analysis of variance is a analysis of variances. All right, so what it actually does is it compares. The analysis of variance compares the difference between this sample to this sample to this sample set. All right, so it compares the difference between control, NaCl, sucrose, and it compares it to the natural random variation between the set itself. So here you've got 9 and 8. See, that's a natural variation, all right? And here's a 9, here's an 8, here's a 7. These numbers are different, okay? So that's what the ANOVA will test for, all right? The difference between this and this and this compared to the differences within each set on the natural variances. Okay, here again, natural variance is 6 to 7 to 5. Right here, 1 to 2 to 0 to 5. All right, there's variances within a set itself. So that's what the ANOVA does. And when you set the hypothesis, okay, it has to match that. All right, so here my alternate will be NaCl. All right, sodium chloride and sucrose affects bubble size. Okay, so that tests, all right, that states whether there's a difference or not within these three sets. All right, within these different sets of data, while the null complements it. Okay, now looking at the t-test, it's a comparison between two means slash averages. Okay, so it's a direct comparison. So in this case, with the t-test, it will compare, for example, the average, all right, of this and the average of this, and it'll tell you how significantly different they are. All right, so the difference between just looking at a regular average and the t-test is that it will tell you how different they are and whether you can say they're significantly different or not. All right, now for both of these tools, in science, we want a 95% significant confidence level to accept the alternate hypothesis. If your differences are not 95% different, then you cannot accept the alternate hypothesis. And in that case, you're going to have to accept the null hypothesis, all right? Because if you accept the null hypothesis, there's nothing wrong with that. You're saying nothing has changed, all right? You haven't made a huge contribution to the scientific community or the world of problem solving, okay? However, if you accept the alternate, then you're saying that you have made a contribution to the scientific community, the world of problem solving. you've made a discovery, all right? And that is why, to accept the alternate, all right, both of these tests, you guys need a 95% significance confidence level, okay? It has to be 95% significantly different for you to accept the alternate hypothesis. Okay, I'm going to go on first with the ANOVA and how to use the ANOVA, okay? So here is my ANOVA, okay? Versterstats.net. I can link you guys later on. Okay, first off, number of samples, that will be 3. Control, sucrose, sodium chloride, okay? Correlated samples, all right? Almost always correlated samples, almost always this button, okay? Almost always this button weighted, all right? You want to make sure that the samples are weighted, okay? Now, next, you enter your 3 sample sets of data. Okay, I've got my control, sodium chloride, sucrose. Okay, now you push calculate. So this program, this website will do all these tedious calculations for you, and it will shoot out what's called a p-value. Okay, this is the important value here. It will tell you how significantly different something is. So in this case, it's a 0.001, okay? And the total is out of 1 whole. So this one is 99.9% confident, all right, that you can accept the alternate hypothesis, all right? The p-value, you can think of it as how much of a percentage you should accept the null. Remember, in science, you always want to be unbiased, so you should always expect to accept the null. Okay, so the p-value will tell you how much of a percentage to accept the null. However, in science, you want a 95% confidence level. All right. Now, if that confuses you, I'll stick to it. Simply put, if this p-value is below 0.05, then you accept the alternate hypothesis. All right. If this p-value is above 0.05, then you will accept the null hypothesis. Okay? So that's the key number here, 0.05. All right, and below. You can accept the alternate. You've made a contribution. It's more than it's 95% or more that it's significantly different. Okay? If the p is low, below 0.05, you accept the alternate. If it's above, even if it's 0.051, you still have to accept the null. Okay? Now, if you're using the ANOVA, you also want to look at this Tukey HSD test here. This will also tell you the significance between each set. Okay? Now, do understand that as a whole, you look at this value right here. All right? Whether you accept the hypothesis, the alternate hypothesis, or the null hypothesis, it's always this value. Okay? So in this case, we are accepting your hypothesis alternate, your alternate hypothesis. Now, in the conclusion section, all right, you might want to talk about this. This is your data right here. In your analysis and conclusion section, you have to talk about this. Okay, so this is saying set 1 your control compared to the sodium chloride. All right, there is significant difference. Okay, now here control sample 1 and sample 3 versus your sucrose, there is significant difference. All right, more so than that of the control and the sodium chloride solution. Okay, now however, you may want to mention this. All right, the differences between sample 2, set sample 2 sodium chloride, and set sample 3 sucrose is non-significant. So you do not have a 95% confidence level that this is different enough from this, okay, to say that they are different. Okay, so as a whole, remember, you always just look at this, but you might want to mention, all right, this in your analysis and conclusion and why you think that is. Okay, of course, this is all made up data that I use, so just hypothetical situation. Okay, that is the ANOVA for today. I've run out of time, so I will go over the t-test next.